So now we want to find a value of k for which this graph, g of x, has a normal line whose slope is negative 1/5. And that's going to be at that point of tangency of x equals 1. So what we want to do here is, if we find the derivative of g, we can plug in 1, and we know at that point 1, at that point of tangency, the derivative should be equal to the opposite reciprocal of the normal line, because the slope of the tangent line should be the opposite reciprocal of that, right? So that means the slope of the tangent line, or the derivative, so I'll say g prime of 1, should be equal to 5. That's what this kind of thing means in here. So I'm going to find the derivative of g, set it equal to 5, plug in 1 for x, and solve for k. So g prime of x, k is a constant. So I've got an exponential. The k just comes along for the ride. The derivative of e to the 2x is itself. Again, it's an exponential because the x is in the exponent. Stay away from power rule here when x is in the exponent. The derivative of an exponential is itself, meaning recopy the base and recopy the exponent. Now, the exponent is not just simply x. That means there's an inner function of 2x. So I have to apply chain rule and say times the derivative of the inner, which is 2. Oh, also, in doing my derivative of the exponential, after I recopy it's itself, I'll write this down here. We have to do times the natural log of the base. I didn't mention that because I'm just so used to when the base is e, I don't have to consider the ln of e. Okay, but maybe we have to consider that for now. And then the times 2 is in there for the chain rule. So then it's going to be e to the 2x times 2. And then the derivative of 3x is 3. So now we know that g prime of 1 equals 5. So 5 is going to be equal to k times e to the 2 times 1 times 2 plus 3. So we're going to get 5 equals k e squared times 2 plus 3. So we're going to subtract 3 off both sides. I get 2 equals 2e squared times k. So if I divide both sides by 2e squared, I get k equals 1 over e squared. That's choice B.